everyone. This is Dr. G. Ravindranath Reddy, working as Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. So here we are discussing the numerical methods and integral transform course. In that, we are discussing the Laplace transform of derivatives and integrals in this video. So here we will discuss how to apply the Laplace transform for the derivatives and the integrals of the given function. So first we will concentrate on the Laplace transform of derivatives. So now we will take that statement of this. So L of f of t is equal to a bar of s. Now then Laplace transform of f dash of t. So here we are taking the function f of t. So for this, if you apply the derivative here, you will get the f dash of t. For this function, we are going to see how to find out the Laplace transform for the derivative of f of t. So that is given by Laplace transform of f dash of t is equal to s into f bar of s minus f of 0. So this is the formula we have to remember to find out the Laplace transform for the first derivative of f of t. And similarly, we are having the formula for the Laplace transform of f double dash of t. Laplace transform of f double dash of t. So Laplace transform of f triple dash of t. So all this you will apply in the applications of Laplace transform while you are solving the differential equations using Laplace transform technique. So these derivative formulas will be useful. Now similarly, so Laplace transform of f double dash of t is equal to s squared. So since we are applying the second derivative for the function, so here we have to take the s squared. The power of s must be equal to the number of times we have applied the derivative for the given function f of t. So s square into f bar of s minus s into f of 0 minus f dash of 0. The power of s must be in the decreasing order as the number of terms increases. So here we are having s square, here we are having s power 1, so here we are having s power 0, that is 1. So now by analyzing this Laplace transform of f dash of t and Laplace transform of f double dash of t, we are going to derive the general formula for the Laplace transform of nth derivative of f of t. So in general, so Laplace transform of nth derivative of f of t is equal to, here since we are applying the Laplace transform for the second derivative, so we have taken s square here. Now here we are applying the Laplace transform for the nth derivative of f of t, so the power of s must be n. So s power n into f bar of s. In the second term, the power of s must be decreased by 1. So here you will get s power n minus 1 into f of 0. And next, when you come to the next term, the power must decrease by 1. So s power n minus 2 into f dash of 0 minus, and so on. We have to continue until we will get s power 0. So here whenever we take f double dash here, so we are ending that formula with f dash. So we are taking nth derivative of f. So here the last term must be its previous derivative, n minus 1th derivative of f of 0. So this is the standard formula we will use. Based on this derivative, we can apply here the Laplace transform. Now we will take some problems on this Laplace transform of derivatives, and we will take when we can apply this Laplace transform of derivatives formulas. So now let us take, using the theorem on the transform of derivatives, find the Laplace transform of the following functions. So I will take this function t into sin at. So now whenever that any function is multiplied with t, then we will see how to find out this Laplace transform of t into sin at using this Laplace transform of derivative formula here. So first take the function. So for whatever the function we are going to take, you represent that function as f of t. So f of t is equal to sin at, and find out the derivative of this. F dash of t is equal to sin at. So derivative, apply uv formula here. Derivative of uv. So we can take u into v dash plus v into u dash. So here u is equal to or we can take anyone. We can consider u as t, or we can consider v as t here. So we don't have any conditions in order to apply the derivative of uv here. Which one we have to consider as u and which one we have to consider as v. So as you like, you can consider anything, any function as u and any function as v. So now use this formula, you will get this f dash of t. Now f double dash of t here, you find out that f double dash of t. So we have to find out the derivative until we get the term t sin at in these derivatives here. So in the first derivative we don't have t sin at, so we got only sin at here. So because of this reason I want to go for the f double dash of t here. So in this, after finding that f double dash of t, here you are having that term t into sin at. So you up until we get this function, whatever the function he has given in the problem, that function must be in the derivative values here. In the first derivative we don't have t sin at, so I came to the second derivative, f double dash of t is equal to, we got this value. So in this we are having the term, the function t sin at, which is given in the problem. So now use this and get the value here. Now similarly we want f of 0 and f dash of 0 here. So this we have considered that f of t is equal to this value t into sin at. Now take t is equal to 0 here. So if you take f of t is equal to, we got this f of t is equal to sin t sin at. Now you substitute t is equal to 0. So replace t with 0 here. 0 into anything equal to 0. So you will get f of 0 is equal to 0. And already we got f dash of t is equal to, we got f dash of t is equal to sin at plus a into cos at. Now here also you substitute t is equal to 0, you will get f dash of 0 equal to sin 0 plus a into t, replace 0 and this is 1. So sin 0 is 0, 0 into anything equal to 0, you will get that f dash of 0 is also equal to 0. So now f of 0 and f dash of 0, we got that values are equal to zeros. So now we are ready to use this Laplace transform formula. So we have stopped the derivative with the second derivative f double dash of t. So Laplace transform of f double dash of t, you take that formula s square into Laplace transform of f of t, that is, so we have the formula s square into f bar of s. So this f bar of s we can consider, we can take it as Laplace transform of f of t. So s square into f bar of s, that is can be written as Laplace transform of f of t minus s into f of 0 minus f dash of 0. Now replace all this here. So whatever the value we got for the f double dash of t, you replace that value here. So Laplace transform of 2a cos at minus a square into t sin at is equal to s square into L of Laplace transform of f of t. We have taken that f of t is equal to sin at minus 0, and since f of 0, we got that f of 0 is equal to 0, 0 into anything equal to 0 minus f dash of 0, we got f dash of 0 is equal to 0 here. Now simplify this, apply the linearity property here. So 2a is a constant, so we can take the 2a outside this Laplace transform. So 2a into Laplace transform of cos at minus a square. A square is also a constant here, so we can take that a square outside this Laplace transform. So Laplace transform of t sin at, you bring this to this side, s square minus t Laplace transform of sin at to this side. So you will get this RHS value, RHS side is equal to 0. Now you take this Laplace transform of t sin at, Laplace transform of t sin at. From these two we can take Laplace transform of t sin at as a common. Here you will get minus of s square plus a square is equal to, send this 2a to this side. So you will get 2a into Laplace transform of cos 80. So Laplace transform of cos 80, we can take this value is equal to s by s square plus a square. And here we are having 2a. If you send this term to this side, it becomes minus this. So now we want this value Laplace transform of t sin 80. So send this coefficient to this side. So this minus and this minus gets cancelled. So you will get Laplace transform of t sin 80 is equal to 2a s sub by, if you bring this denominator s square plus a square to this here, it becomes a denominator. So already here you are having s square plus a square. So once again we will get another term as s square plus a square. So we can take it as s square plus a square whole square in the denominator. So this is the way how we can apply this Laplace transform of derivative for the t sin 80. So we can also get the Laplace transform of t sin 80 by using our standard formula Laplace transform of t into f of t, which we will discuss in the next video. So whenever we are having some function, for that function if you want to find out the Laplace transform, one or more properties will be useful to evaluate that Laplace transform value for the given function. So we can also find this, we got this value by using the Laplace transform of derivative formula, and also we can apply the property, another property, that is Laplace transform of t into f of t. So by using this also we can get this same value 2a s by s square plus a square whole square. So anyone whichever we are comfortable, we can use that property and we can find out that Laplace transform of the given function here. Okay. Now we will take this next topic, Laplace transform of integrals. So when we can apply this Laplace transform for the given function. So whenever that inside the Laplace transform we are having some integral 0 to t f of t dt. So inside the integral if we have some inside the Laplace transform if we have some integrals of the form 0 to t, integral 0 to t f of t dt, then by default we can choose this Laplace transform of integral formula here. So now let us take the statement of this Laplace transform of integrals. So L of f of t is equal to f bar of s, that is Laplace transform of f of t is whatever the value we get for the Laplace transform of f of t, that we can consider as f bar of s. Then Laplace transform of integral 0 to t f of t dt. So integral 0 to t f of t dt. So inside the Laplace transform if you have an integral of the form 0 to t, then if you want to find out the Laplace transform of this integral, then we can use this standard formula, that is f bar of s by s, or we can take 1 by s into f bar of s. And similarly, suppose if you have two integrals inside the Laplace transform, then we can use the same formula. So since here we are having a single integration, so we have taken 1 by s. So whenever we are having two integrals inside the Laplace transform, then the power of the denominator s is increased to 2. So since here we are having two integrals, so we have to take the power of s as 2 in the denominator. And similarly, if we have Laplace transform of inside the integral, if we have inside the Laplace transform, if we have three integrals 0 to t, integral 0 to t, and the function is f of t dt, and dt, then this value, this Laplace transform value is given by 1 by s power. So inside the integral, inside the Laplace transform we are having three integrals, so the power of s must be 3 into the function f bar of s. So here f bar of s, how can you get this f bar of s here? By taking the help of f of t, apply the Laplace transform for f of t, then whatever the value we get for Laplace transform of f of t, replace this, you will get our Laplace transform of integral value. Okay, now by using this formula we will see how to find out this Laplace transform of that integrals. So now this is the function he has given, integral 0 to t sin t by t dt. So here first you find out this. So here once if you have an integral of the form integral 0 to t, then by default you go for the Laplace transform of integral formula. So what is our standard formula? Laplace transform of integral 0 to t f of t dt is equal to f bar of s by s. Now whatever the function we are having inside this integral, you consider that function as f of t here. So our function is f of t is equal to sine t by t. Now we want f bar of s here. So how can you get this f bar of s? So this f bar of s can be written as Laplace transform of f of t and the denominator s. Now our task is, if you want to complete this problem, Laplace transform of this integral, just it is enough to find out the Laplace transform of that f of t, that is Laplace transform of sine t by t. So once if you complete this in Laplace transform, then we can complete our problem here. So before going to find out the Laplace transform of sine t by t, first I will find out the Laplace transform of that sine t, because we are having a standard formula. So that is 1 by s square plus 1. You consider this as some value f bar of s. And now integral 0 to t f of t dt, we are having this formula f bar of s by s. Now our problem is Laplace transform of sine t by t is equal to, this is of the form Laplace transform of f of t by t. So this is a standard formula which we discuss in the next video. That formula is given by integral s to infinity f bar of s into ds. Now use this formula. So here integral s to infinity f bar of s, here this can be written as s to infinity. So this, whenever we want to apply this formula, the numerator we have to consider as f of t. So you will get Laplace transform of sine t into ds. So Laplace transform of sine t is given by 1 by s square plus 1 into ds. Now apply this integral of, apply this formula, 1 by x square plus 1 into dx. So this can be written as tan inverse x. So use this. So you will get tan inverse of s. The limits are s to infinity. First substitute the upper limit. So tan inverse infinity minus tan inverse s. So tan inverse infinity, this can be written as tan inverse of infinity, you will get tan pi by 2. So tan inverse of tan pi by 2, you will get pi by 2 minus tan inverse s. So pi by 2 minus tan inverse s, we can take this value is equal to cot inverse s, or we can take this as tan inverse of 1 by s. So here the meaning of this one is, whenever we have integral inside the Laplace transform, then we can use this Laplace transform of integral formula. So whatever the value we want, so here in the Laplace transform of integral we are having the f bar of s value. So whatever the function we are having inside the integral, you consider that value as f of t. Now apply the Laplace transform for f of t, you will get f bar of s. Now you substitute that value in this standard formula, then we can complete our problem. So now while you are finding this Laplace transform of f of t, then we have to use other properties of Laplace transform, and we have to get this f bar of s. So here while you are solving this Laplace transform of sine t by t value, we are using the property Laplace transform of f of t by t. We have used this one. Now by using this property, we have the formula integral s to infinity f bar of s. You find out this value by using this formula, then you can get our Laplace transform of sine t by t, that we have to consider as f bar of s value here. So this value you replace in this standard formula, we can get our required one. So now we got this value here, that is pi by 2 into tan inverse s. So you consider this value as f bar of s here. Now finally Laplace transform of sine t by t is equal to, we got this value, this is our f bar of s. Now after getting this f bar of s value, replace that value in this formula here. So Laplace transform of integral 0 to t sin t by dt is equal to, so have taken this value as f bar of s, so 1 by s into tan inverse of 1 by s. Otherwise we can take it as 1 by s into cot inverse of 1 by s. Otherwise we can also write it as 1 by s into, we have another value here, pi by 2 minus tan inverse y. We can also write this value here. So 1 by s into tan inverse of s. Out of these three we can consider any one here. So this is the way how we can apply the Laplace transform of integrals. So whenever we want to apply the Laplace transform of integral, inside the Laplace transform we must have integral 0 to t form and some function and integration with respect to t. So this is our standard formula. So inside the Laplace transform, if we have this integral 0 to t, then we can go for the Laplace transform of integral and we can apply this formula and we can find out that Laplace transform value here. So now here we have discussed when we can use this Laplace transform of derivative formula and when we can use this Laplace transform of integrals. So by taking some examples here. So in the next video, we'll go how to find out the Laplace transform whenever that f of t is multiplied with t, that is t into f of t, and similarly whenever that f of t is divided with t, that is f of t by t. So how to find out the Laplace transform of t into f of t and Laplace transform of f of t by t. So these two topics we are going to discuss in the next video. Thank you.